Good afternoon, Year 7, and welcome to today's maths lesson. Let's start off with a quick starter, shall we? Can you work out these 7 questions for me in your rough books or on your mini whiteboards or on a scrap piece of paper, whatever you have to hand? And if you finish, can you have a go at my extension question on the other side of the board? Please pause the video for 5 minutes or so and have a go at those questions now. Okay, let's go through the answers. So for the first one, 901 subtract 476 will give you 425. If you'd done a bus stop division, you'll have got 1,633. A multiplication using grid or column would have given you 6,152. 45 times negative 1. Now if we multiply a number by negative 1, we just get its inverse, which is negative 45. 7 squared plus 3 squared, well 7 squared is 7 times 7, which is 49. 3 squared is 3 times 3, which is 9. If I add those together, I get 58. 53 subtract 87 would give me negative 34 because I've got my smaller number taking away my bigger number. And finally, if a is equal to 3, 3a plus 1 would be 10 because 3 times 3 is 9 and 9 plus 1 is 10. If you'd done my extension question, the answer I was looking for was £469.35. Well done if you got that right. We're going to run through the diagnostic quiz now, so 5 questions, A, B, C or D. Write down your answers in your rough books and then we'll go through the answers at the end. At any point you can pause the video to have a little bit more time to think. Off we go. Question number 1. Can you expand this bracket for me? 3 lots of p plus 1. Feel free to draw out the algebra tiles to help you out, using the green rectangle to represent p. Question number 2. What are the correct values of x and y? What are the correct values of x and y? Question number 3. What is the perimeter of this shape? Watch out, you haven't been given this length here. What is the perimeter of this shape? At any point, pause the video to have a little think. Question number 4. Can you expand this bracket for me? Again, use your algebra tiles. Use the green rectangle to represent p. Can you expand this bracket? Remember, the 3 tells us how many rows we need, and the p subtract 1 tells us how long the column is. And finally, which of these calculations give the greatest answer? Use your BIPs, your brackets, indices, products, and sums to work it out for me. Okay, I'm going to run through the answers. If you want to pause and rewind and have a look at one of the questions again, now's your chance to do so. Question number 1. If I'd expanded that bracket, I'd have got 3p plus 3, so the correct answer was A. If we draw it out, I know that I need 3 rows of rectangle plus a square, where the rectangle is green, which is p, and the square is yellow, which is 1. If I have 3 rows of that, I've now got 3 lots of p plus 3, so the correct answer was A. For question number 2, the correct answer was D. For question number 3, the correct answer was C, 45 centimetres. For question number 4, if I expand this one, let's see if I can draw it out. If I have a green rectangle to show P, or X, I know I need 3 rows of it. For negative 1, I need a red square, and I know I need 3 rows of it. So my column length is p subtract 1. I've got 3 rows, so altogether I've got 3p and negative 3, so the correct answer was A. And for the last question, the greatest answer was given by D. Let's do a quick recap of last lesson. I asked you to solve this equation. I had a green rectangle and 2 yellow squares is equal to 3 yellow squares. Now to solve the equation, I needed to add something to both sides of this equation that will leave me with just the green rectangle on one side. I've got a green rectangle and 2 yellow squares currently, so I need to add 2 red squares so that I'm left with just the green rectangle, because I can now cancel out my 0 pairs. But we showed last lesson that to remain equal, whatever I add to one side of the equation, I had to add the same to the other. So I need to add 2 red squares to this side of the equation as well. If I cancel out my 0 pairs, this shows me the green rectangle is equal to 1 yellow square. Over to you guys, in your rough books or on your mini whiteboards, solve this equation. Feel free to pause the video for a minute while you work it out. Okay, I'll go through the answer. To solve it, I need to be left with just the green rectangle on the left side of the equation, and to do that I need to add 4 red squares. But whatever I do to one side of the equation, I need to make sure I do the same to the other so it remains equal. If I now cancel out my 0 pairs, I'm left with just the green rectangle on this side, which is what we wanted. And my green rectangle is going to be worth 2 yellow squares. On your mini whiteboards or in your rough books, solve this equation for me. Feel free to pause the video. Okay, let's go through it. To get just the green rectangle, I need to add 2 red squares. Whatever I do to one side, I must do the same to the other. If I cancel out my 0 pairs, I'm left with the green rectangle is equal to 1 yellow square. How good are you, Year 7? How about now? What do I need to add to be left with just the green rectangle? And what's the green rectangle worth? Solve this equation. Okay, this time to cancel out those 2 red squares, I need to add 2 yellow squares. And if I do it to one side, we know I have to do it to the other. If I cancel out my 0 pairs, I'm left with the green rectangle is equal to 5 yellow squares. How about now? How are you going to solve this equation? This time I need to add 4 yellow squares to cancel out those 4 red squares. Whatever I do to one side, I need to make sure I do it to the other. If I cancel out my 0 pairs, I'm left with the green rectangle is equal to 7 yellow squares. How about now? Solve this equation for me. Pause the video. Okay, this time I need to add 4 red squares to be left with just the green rectangle. Whatever I do to one side, I need to make sure I do the same to the other side. If I cancel out my 0 pairs, I now know my green rectangle is equal to 7 red squares. How about now, Year 7? What are you going to do? Okay, let's go through it. I need to add 4 yellow squares to cancel out those 4 red squares, so here they come. Whatever I do to one side, I need to make sure I do exactly the same to the other so it remains equal. If I cancel out my 0 pairs this time, I've got 0 pairs on both sides of the equation, so I need to cancel out both sets. So my green rectangle is worth 1 yellow square. Now we're going to add in letters. So in your dark blue books, can you write me either a new title that says solving equations or carrying on from where we left off? However, I need a new date, which is the 17th of December. I'll go through an example and then there's one for you to do. I've been asked to solve the equation x plus 3 is 5. I'm going to model this using my algebra tiles. Now x is a green rectangle and plus 3 is 3 yellows. I know that's equal to 5 yellow squares. To solve it, I want to add something to both sides of the equation, so I'm left with just the green rectangle on the left side. I need to add 3 red squares. Let's cancel out some 0 pairs. There's 1, there's 2, there's 3. I can cancel out 0 pairs on the other side, and I'm left with the green rectangle is equal to 2 yellow squares. And that tells me that the green rectangle X is equal to positive 2, because the yellow squares are each worth positive 1. In your dark blue books, by modelling with the algebra tiles, can you solve the equation on the right side for me? Pause the video for a minute and have a go at that now. Okay, let's go through the answer. This time I've got a green rectangle X plus 2 yellow squares is equal to 7 yellow squares. And those two are equal. I now need to add something to both sides of my equation that will leave me with just the green rectangle. If I add 2 red squares, I can then cancel out my 0 pairs, and I'm left with the green rectangle, or X, is equal to 1, 2, 3, 4, positive 5. I'll go through another example and then there'll be one for you to do in your dark blue books. So I'm going to go through X plus 4 is equal to 2. I'm going to model it in the same way. The green rectangle represents X, and I need 4 yellow squares to show positive 4. I know that's equal to positive 2. Now to solve this, I want just the green rectangle on one side, so I need to add 4 red squares to cancel out those 4 yellow squares. But whatever I do to one side, I need to make sure I do exactly the same thing to the other, so both sides remain equal. If I cancel out my 0 pairs, like so, I'm left with my green rectangle, X, is equal to 1, 2, but negative 2 this time, because each of the red squares means negative 1. Over to you, Year 7. In your dark blue books, please pause the video for 5-10 minutes and have a go at this one for me. Model it out using your algebra tiles. Take as long as you need, step by step. Can you solve this equation? Okay, let's go through the answer. This time I've got X, which is my green rectangle, plus 5 yellow squares is equal to positive 3. I want just my green rectangle on this side of the equation, so I'm going to add on 5 red squares. Whatever I do to one side, I need to make sure I do the same to the other side of the equation. Now I can cancel out my 0 pairs. There's 1, there's 2, there's 3, there's 4, and there's 5. I've got 0 pairs on the other side of the equation, so I can cancel those out as well. And I'm left with my green rectangle X is equal to negative 2. 2 lots of negative 1 red squares. Can you switch to your light blue books for me, or on your mini whiteboards, and solve these equations for me in the same way? Pause the video for 10 minutes or so and have a go at these. There's some extension questions. If you're confident, off you go. Okay, hopefully you paused the video for 10 minutes and had a go at those questions. The answers, question number 1 was X is 2, 2x is 3, 3x was 1, question 4, x was 3, question 5, x was negative 1, question 6, x was negative 3, question 7, x was negative 5, question 8, x was negative 7, question 9, x was negative 4, question 10, x is negative 5, question 11, x is negative 5, and question 12, x is negative 2. If you had a look at my extension questions, for the first one, you've got x is equal to 1. For the second one, you'll have got x is equal to 2. And for my third one, you'll have got x is equal to 5. For those, you need to divide by 2 at the end. Here are some further questions. If you got the first set wrong and you want more practice, please have a go at these now. Pause the video for 5 minutes. And these are the answers if you had a go at these further practice questions. We're going to move on to something slightly trickier. In your dark blue books, I'm going to go through an example and then there'll be one for you to do. This time I've got x, a green rectangle, subtract 3 red squares, is equal to positive 2 yellow squares. Again, I want just my green rectangle on one side of the equation, and to do this I need to add 3 yellow squares to cancel out those 3 reds. Whatever I do to one side, I need to make sure I do the same to the other. Now I can cancel out my 0 pairs, off they go. And I'm left with x, my green rectangle, x, is equal to positive 5 yellow squares. Pause the video for a minute and have a go at modelling this one and answering this equation in your dark blue book now. Okay, let's go through the answer. This time I've got x, my green rectangle, subtract 4, for which I need 4 red squares, is equal to 2 yellow squares. To cancel out those 4 red squares, I need to add 4 yellow squares. And whatever I do to one side, I need to make sure I do the same to the other. Now if I cancel out my 0 pairs, I'm left with x is equal to positive 6. 6 lots of positive 1. Let's go through another example in your dark blue books. I'll go through one and then there'll be one for you to do. This time I've got x, my green rectangle, take away 3 reds, is equal to negative 2. To cancel out those 3 red squares, I need to make sure I add 3 yellow squares. There they are. And whatever I do to one side, I need to make sure I do exactly the same to the other. Let's cancel out some 0 pairs. There's 1, 2 and 3. And I do the same to the other side. That tells me my green rectangle x is equal to positive 1 in this case. In your dark blue books year 7, pause the video for a minute. Here's one for you to do. Okay, let's go through the answer. I know that x on its own, subtract 4, is equal to negative 2, for which I need 2 red squares. I want to get the green rectangle on its own, and to do that I need to add 4 yellow squares to this side, and whatever I do to one side I need to make sure I do the same to the other. If I now cancel out my 0 pairs, I'm left with my green rectangle, x, is equal to positive 2, my 2 remaining positive 1 yellow squares. Please switch to your light blue books now, year 7, and pause the video for 10 minutes and have a go at these questions. Can you solve these equations? Extension questions if you're confident. Off you go. And these are the answers I was looking for. Please check your work and see how you did. If you did my extension questions, for the first one I was looking for x is equal to 5. For the second one you've got x is equal to 7. And for the third one, well done if you got this right, that would be x is equal to negative 2. Well done if you got that one, that was a tricky one. And that's the end of today's lesson. Thank you for listening, year 7. Could you please now head over to Google Classroom and submit today's exit ticket on there so I can see how you got on and help you out. Thanks very much and have a wonderful afternoon. Bye bye.